Solutions to homework 4. Okay, so I think number 4 was pretty easy, right? I don't mean homework 4, I mean literally problem 4. So if we look here, it just wants to know what would be the output for the following operations. So let's take a look at A. Notice that we have all pluses. And so what this means is that we're doing an OR operation. So this would be the same as having a logic circuit that looked like this, where we had 0, 0, and a 1 coming in. So remember, with an OR gate, as long as any of our inputs is a 1, then our output is going to be a 1. And so A would be 1. Notice for B, we have an OR gate with all 1s coming in. So B is going to be 1. C, notice we're using multiply. And so that's an AND gate. That looks like this, where we have a 1 coming in, a 0 coming in, and a 0 coming in. Remember, for an AND gate, all of its inputs have to be true for its output to be true. Since 2 of the inputs are a 0, our output's going to be a 0 for C. D, we have an AND gate with all 1s at the input. Since they're all 1s, the output's going to be a 1. For E, again, we have an AND gate, but one of the inputs is a 0, so the output's going to be 0. And then here's where it starts to get trickier. And so let's look at F. For F, we have, let's sort of draw it out. We have an AND gate that has 2 1s coming in. We have the output of that going to an OR gate. And then we have another AND gate that has a 0, a 1, and a 1 coming in. So that looks like this. And so what would our output be here? Because notice, we have these two ANDed, we have these two ANDed, and then the two of them here are ORed together. Well, the output of this AND gate here would be a 1, because all of its inputs are a 1. The output of this AND gate would be a 0, because one of its inputs is a 0. And finally, if we OR a 1 with a 0, we get a 1 at the output. And so the output of F would be 1. We're going to do an example where we build circuits in just a second. I realize I didn't really show you that in the lecture, how to go from equation to circuit, but I'm going to go over that much more slowly in the homework here. Okay, so let's look at the Morgan's theorem. This is going to be important because the Morgan's theorem is pretty much always the first step of reducing circuits. So let's take the first one. I might not do all of them. Maybe I'll do all of them. I don't know. We'll see how it goes. Let's start with A. So for A, we have A, B naught, ANDed with C or D naught, and then the whole thing ANDed. So remember, step 1, always work from the top down and don't skip any steps. So, if I bring this down, I see that I have it over A naught. It's over an AND gate here, so that becomes an OR. Then we have B, which now has double knots. And again, we'll get rid of this in the next step, but I try not to skip any steps. We have an AND gate there implied, so that becomes an OR. Then we have our parentheses. I'm going to leave it all just like it is for right now, because I see it over this whole thing. And again, I recommend you do it that way. You'll end up making less errors if you do it that way. Alright, so now let's go ahead and reduce this one. That gives me A naught, or B, since we have 2 knots, it goes away, cancels it out. OR, and now we have C naught, this OR becomes an AND, D double knot. And then finally, I can just get rid of that double knot. B or C naught, D. And so that's A. Let's try B. So for B, we had A. Let me actually keep it so I can keep the original there. So for B, we had A, B, C, D, or E, F. And the whole thing had a bar over it. Alright, so these are the ones we want to take really slowly to make sure we don't mess up with one of the ANDs or ORs. And so I see this over the A, the AND, the B, the AND, and this whole thing. So I'm going to do A naught, or B naught, or, and then this whole thing in parentheses, C, D, or E, F, all with the overbar. Alright, now let's go. So we have A naught or B naught or. Now we gotta be really careful. We're turning an OR to an AND with a bunch of stuff on either side. This is why I said do it step by step. What I'm gonna do is I'm gonna say I see it over this, this, and this. So all three things. So that's gonna leave me with CD. And notice, because this is becoming an AND like that, I'm going to want parentheses around these, like that. And so that's going to be A naught or B naught or C naught or D naught, ANDed with E naught or F naught. And again, that's why it's so important to take it step by step, is because whenever you go from something complicated to, basically, whenever you switch an OR to an AND like this, you want to be careful and use parentheses. Alright, so this is our answer for B. Let me do a few more of these. So for C, I don't know, which ones do you want me to do? Which are the hardest? Maybe I should just do them all. For C, we had A or B naught or C or D naught. Or A, B, C, D naught with the bar over it. And this had a bar over the whole thing. Alright, so a lot going on here, step by step. I see this first over bar over A naught, this OR becomes an AND. B naught, this OR becomes an, B naught, sorry. This OR becomes an AND. C naught, this OR becomes an AND, and D naught naught. So that's what we have for the left side. Or, over on this side, we get A naught, or B naught, or C naught, or D double naught. Alright, and this is going to leave me with A naught, B, C naught, D, or A naught, or B naught, or C naught, or D. Alright, so that's C. Let me drag this over so I can keep working on these. Alright, so for D, we had A naught, B, or C, or D. All of this is in parentheses, ANDed with A, B naught, C naught, D. And then we have an overbar over this, an overbar over this, and an overbar over that. Okay, so here's why we want to take it step by step. Remember, we start from the top and work our way down. So the first thing I see is I see this big overbar over all of this, over the AND gate here, and over all of this. And so when I break that down, that's going to give me A naught, or B, or C, or D, overbar, overbar. This AND becomes an OR, A, B naught, C naught, D, overbar, overbar. So notice, since we started from the top and we took it step by step, notice that these two here cancel out. Boom. These two here cancel out. Boom. And we're done. Notice I can't simplify it anymore. We only have one overbar over each one. So this problem looked really complicated, but because we started from the top, it was able to wipe out a whole bunch of stuff. And so that's our final answer. And then the last one, just move it over. For the last one, we had E. We had A, B, overbar, C, D, or E naught, F, A, B, overbar, or C, D, over bar. And then the whole thing had a bar over it. So again, we're going to take it step by step. I see that first bar over these two things. I see it over the and. I see it over this big thing. I see it over the and I see it over this big thing. And so I'm going to break it down just like that. A, B, not, or C, D, or E, not, F, over bar. I see it again over this and, so that becomes an or. A, B not, or C, D, not, over bar. Alright, so that's our first step. Now let's take it again. The two over bars over A, B cancel each other out. Or, notice I have an or going to an and, so I got to be really careful again. We need to use parentheses. So I see it over three things. The CD, the or, and the EF. So CD not, this or becomes an and, E not F, and that has an over bar. Or, same thing going on over here. So A, B not with an over bar, C, D not, and the over bar. So I notice it looks like it takes longer because I'm breaking it down step by step. Trust me, you're going to save yourself from a lot of mistakes. In the end, it'll be quicker. Alright, so now we have A, B, or, C not, the and becomes an or, D not. Here we're left with E double, or F not. Over here the same thing. So we have A not, the and becomes an or, B double not. And then over here, notice because we took it step by step, this actually cancels out. And so we have ANDed with just CD. Finally, just get rid of those two that cancel. C naught or D naught. Two cancel here, so we just have E or F naught. Or A naught or B, because they two cancel. All ANDed with CD. And so this is our final answer. So that was a tough one, but notice by taking it step by step, we were careful not to make any mistakes. Okay, so this one was way too easy. Your book didn't have any good circuits to go over like we did in the lecture, but we'll do it. Remember, you always want to start on the input side, and at the output of every gate, write the whole circuit up to that point. So on the first one, this is just a simple AND gate. And so the output X would be A, B, C, D. So we wrote it out like this. It would X equals A, B, C, D. This one, again, we start over here and work our way. The first output would be A ANDed with B. And we can see this is an OR gate. And so our final would be A ANDed with B or C. Here we have A naught. Then at the output of this one, we have A naught ANDed with B. And then you got to be careful here. Notice it's ANDing the whole thing. So the output of this would be X is equal to A naught B and the whole thing ANDed. And then finally for this one, we have A or B. And then just remember, whenever we have something more complicated than just a single letter coming into an AND gate, we want to use parentheses. So this would be A or B ANDed with C. It's really important that you have the parentheses here. And that's it for that one. Next up, draw the logic circuit. So I need to kind of apologize here. I didn't really go over any examples like this at all in the lecture. So I hope you were able to get it. If you're not, you should have contacted me. But I still should have gone over it more. Let's do it now. So the key to these problems is we want to start in one of two ways. We first either want to look at the big thing that's happening. So the big thing that's happening here is an OR. And so I can see that I have this ORed with this. And so I know my last gate is going to be an OR, but coming into that OR, I have two AND gates. So I would have A, B, this is for problem A. Notice that B first goes through an inverter. And so I have A. Those two get ANDed. Now on this, and note, so those two get inverted. I'm also going to have another AND gate. One of those inputs is going to come from A, but it's going to be inverted. And then the other input is going to come from B. So that would be this one before it gets inverted. And so notice how I drew this all coming from the same A and B. That's kind of the best way to do it, but if you just put another A and B, that's fine too. So these two get ANDed, and then they go to an OR gate. And so that's our first one. And again, remember, if you're unsure if you did it right, just write out the equation for it. Right? So here we would have B naught, here we would have A naught, and so the output of this first one would be A, B naught. The output of this one would be A naught, B, and then the output of this would be A, B naught, or A naught, B, which is the same from what we started. So notice, if you're ever unsure, you can basically just work backwards to test your work. By the way, this here is actually an XOR gate. That's the circuit for an XOR gate. Alright, let's try the next one. Okay, again for the next one, notice that the big gate at the end is an OR. And that OR has 3 AND gates feeding it. So this one's more complicated. I'm just going to write multiple A's and B's. So we can see first we have A ANDed with B. Then we have A naught ANDed with B naught. And this is what I mean by writing multiple A's and B's. It's a little bit better if you do it this way, but it's fine if you do it this way. And then we have, again, A naught ANDed with, in this case, notice we have 3 inputs, B and C. And all 3 of these go to an OR gate. Again, we can check our work. Here I have AB. Here I have A naught ANDed with B naught. And here I have A naught ANDed with B, ANDed with C. And so if all 3 of these go to an AND gate, that's going to give me this right here. And you can see that's the same thing we had at the beginning. Let me just pull this over. Alright, for C, now here's what I want to teach you. If you have parentheses, like we do in these two, start in the innermost and work your way out. So anytime you have parentheses, start innermost and work your way out. So for this first one, I see that the first gate I'm going to do is C ORed with D naught. So I have C, I have D. They both, D gets inverted, and then they both go into an OR gate. Now, after that, it goes into an AND gate that has A inverted, and B goes straight in. And so that's it for this one. So again, we have C, it's an OR gate. Here we have D naught, here we have A naught, here we have C or D naught. That comes into an AND gate, and it's more complicated than a single letter. That gets ANDed with A naught and B. And so you can see that's the same as that. Remember, the position of multiplications doesn't matter. Alright, let's do the last one. Again, I want to work inside out. So I can see I start with B ORed with C inverted. So that's the inner one. After that, it gets ANDed with D. Alright, after that, it gets ORed with C. I'll do this one by taking the same ones. So we have C. After that, so we've done this much. Now it gets ANDed with B. And then finally, it gets ORed with A. So we have A down here. And that's it. We can check our work. So from here, we have B or C naught. Here it's more complicated in a single letter, so I'm going to use parentheses. B or C naught ANDed with D. Here we have an OR again. So we have B or C naught in parentheses ANDed with D or, which one was that? B? No, C. The C coming in. Or C. Again, here we need to use parentheses. I'm going to write it up here. So on one side, we have B or C naught D, ANDed with B or C naught ANDed with D or C, and this whole side gets ANDed with B. And then finally, this one here is where we just take that whole thing and OR D. And you can see that that whole thing is the same as right there. And so that's it. If you still have questions about these, just let me know. Next up, using Boolean algebra to solve. So remember how we do these. Step 1, De Morgan. Step 2, distribute. Step 3 is to simplify. Alright, so for A, notice that we can't really De Morgan it. We only have an overbar over a single letter. So the next step is to distribute. So multiply this times this, and this times this, gives me A or AC. Then this times this, and this times this, gives me A naught, no, not A naught, gives me A, B naught. Notice I'm writing it in alphabetical order. That'll make it easier to see the patterns. Or B naught, C. So what's the first thing we can do? Well, remember I can always replace a double A with just an A. So that's going to give me A or AC or A, B naught or B naught, C. Remember now, whenever I see a letter by itself attached to other stuff, that should immediately let me know I can pull that letter out. And so if I do that, I have A, 1 or C or B naught. And remember, if I have or B naught C, and remember, if I have anything ORed with 1, that whole thing goes away. And so that leaves me with A or B naught C. So that is our final answer for the first one. Let's try the next one. So for B, we have A naught B or A naught B C naught or A naught B C D or A naught B C naught D naught E. And you lots of times get equations like this when you do a circuit. So this one's a little tricky, but notice, just like before, I have A naught B by itself attached in all of these equations. And so remember, it can be one letter by itself, but it can also be multiple things attached by a bunch of other stuff. So what I want to do is I want to pull that A naught B out. So if I pull that A naught B out, then I have 1 for this one, or C naught for this one, or CD for this one, or C naught, D naught, E naught, or E for this one. And notice, again, we have 1 ORed with a bunch of other things, so that all just becomes 1, leaving us with just A naught B. Look how easy that was, and how much we were able to reduce it. So that's the second one. By the way, the reason I'm able to cross all that out is, remember, this here would become A naught B ANDed with 1, and anything ANDed with 1 is just A naught B. So that's how we're doing this. Next up, we have C. which is AB or AB not C or A. So remember, our first step here is we always want to do De Morgan's. And so I'm going to do De Morgan on this first. And so if I do that, I have A, let me switch to yellow so we can see the difference, A, B, or, now notice that this De Morgan's is only over those two. And so that's going to leave me with A naught or B naught, C, or A. So now I'm going to multiply it all out. We've got A, B, or A naught, C, or B naught, C, or A. So what can we see here? Well, the first thing I can do is I can notice I have an A by itself attached to something else. So let's pull that out. A. So that's going to give me B for this one, or 1 for this one, or A naught C, or B naught C. Again, because we have something ORed with 1, that just becomes 1. And so we have A, or A naught C, or B naught C. Now this one's really tricky. This is one of those ones where we have that rule that we have to memorize, one of the hard rules. And so what I'm going to do is next week, I'm going to show you a way so that if you don't feel comfortable with this substitution, we actually have a way of guaranteeing we get to the simplest circuit without doing it this way. And I'm going to show you that next week. But for now, remember this is a rule. If I have A or A naught ended with something else, remember either this is a 1, or if this isn't a 1 and this is a 0, then C needs to be 1. And so we had a rule that said that's actually just A or C or B naught C. So that becomes this here. And so finally we can pull out the C because we have a C by itself and we have it attached to something else. So A or C, 1 and B naught. And again, because we have a 1 here, this just becomes 1. And so we have A or C. This one I think is probably the trickiest one on here because again, you have that weird rule that's a little bit more difficult to remember. But like I said, we'll have a way so we don't have to remember it in just a few lectures. Alright, let's try D. So for D, we have A or A naught, A, B, or A, B, C naught. So step 1, we don't need a De Morgan, over bar only over one letter. Step 2, multiply everything out. And so that gives me A, B for this times this, or A, B, C naught for this here times this, or for this times this, we have A naught, A, B, or for this times this, A naught, A, B, C naught. Now the first thing we can see right away, we can get rid of this and we can get rid of this. Because notice, this is always 0. We have a value ANDed with its exact opposite. That can never ever be true. Same here. We have a value ANDed with its opposite. That can never be true. Remember, for an AND gate to be true, all of its inputs have to be true. Over here, we have two A's together, so I can just make it 1. So AB, or over here we have 2 together, so we can just make it 1. A, B, C naught. And again, now notice that we have A, B in both, so I can pull that out. And so if I pull that out, I have A, B ANDed with 1 or C naught. And again, this just becomes 1. So AB ANDed with 1. And remember, anything ANDed with 1 is just AB. And so that's that one. One more. Let's check this last one. So in this last one, we have AB or A naught or B naught, C or AB. And so for this one, again, there's no De Morgans that needs to be done, so just distribute everything out. We have AB or A naught C for this times this, or B naught C for this times this, or AB. First thing we can do is notice that we have this one here twice, right? AB with this, so we don't need two of them going to an OR gate. We can get rid of one. That leaves me with AB or A naught C or B naught C. And after this, you can try to pull the C out, which would leave us with AB or C, A naught or B naught. My guess is almost everyone in the class thought this or this was as far as you could simplify it. And this is exactly why we need the next thing I'm going to teach you. This one is incredibly tricky. We could have actually made it a little bit simpler than this. And if you didn't get this right, that's totally fine. This is why we're going to learn K-maps. With K-maps, we can guarantee no one else can get it simpler. But let me show you technically what you could have done here. Notice if I reverse De Morgans, right? This here is the same as A B naught. Because remember, A B naught like that is A naught or B naught like that. And if I change that to that, notice what we have. We have AB or A B naught C. But remember, we probably don't remember. I never remember this rule, honestly. When I have a value like this, or with its exact opposite, like that, that is the same as A, B, or C. That's our rule. Remember, if I have A or A naught C, that's just A or C. Well, if I have AB or AB naught C, that's the same as AB or C. So I'm assuming probably almost no one got this, and that's okay. Notice we had to make it more complicated to make it simpler. But this problem right here, this is why we have the next thing I'm going to teach you in class, K-maps. With K-maps, we don't have to worry about doing we have to do a little bit of it, but not worrying about getting to the final point like this. Meaning, if you do a K-map, you can prove that nobody can make it simpler than you. So that's what's coming up next. And finally, we have our last problem. So again, just like before, we need to write out the equations. So we have C D naught, or B naught. It's coming into an AND gate, so when I write this out, I want to make sure I use parentheses. C D naught or B naught ANDed with A. And this is all going to an OR gate, so I'm going to start to write down here because I'm running out of space. So for A, we have C D naught or B naught ANDed with A. All of that is ORed with A naught B naught C, or A naught B naught C. So that's our first equation. This one here, let's do it in one order. We have A B naught, we have A C D naught, and we have A B naught C. So for B, let me write this above it. So that's A. For B, that's all going to an OR gate, so we have A B naught, or A C D naught, or A B naught C. So that's B. Here we have C D naught, we have C D naught B, and again we should write that in alphabetical order when we're finished. Here we have A B naught, and so our output for C, that's all going to an OR gate, is B C D naught or A B naught. And then finally our last one, we have A B naught, we have A C D naught, and that's going to an OR gate. So we have A B naught or A, C, D naught. Alright, let's look at what we got here. Are any of these the same yet? It doesn't look like they are, does it? So let's try to multiply things out. So here I have A, C, D naught, or A, B naught, or A naught, B naught, C. Is that the same as anything? What do you think? Here, this is already multiplied out, so we have... Yep, nope, not the same. So let's see what we can do with the second one. So for this one, notice that we have A, B naught in both of these. So I can pull that out. So A, B naught, 1 for this one, or C for this one, or A, C, D naught. This goes away, and so I have A, B naught, or A, C, D naught, and boom, we found it. B is the same as D. And so that's it. That's this whole homework. This is probably the most difficult of the homeworks. Maybe the substitution part. I think substitution is what causes, or simplification rather, this part here is what causes students the most amount of difficulty. Like I said, next week we're going to have a way so that we don't always have to solve it this way, and we can guarantee we get to the simplest solution. So that's what's coming up. If you have questions about this, you're still confused, please send me an email. Talk to you again soon.